Good afternoon, dear guests. My name is Mirko Bracht. I'm responsible for the digitalization and system operations and for the product cluster Grid Asset and System with all the product elements around MCCS and OOC. We are very proud today to welcome you in this monumental transformation hall for our Checkpoint 2025 of MCCS. We are here in Neuenhagen at the heart of system operations, and during we are sitting here and enjoying the journey of the Checkpoint event, our colleagues in the control center are quite close to us, and they are responsible in the meanwhile for ensuring the system stability 24 hours a day. This Checkpoint event is a kind of tradition. So every year we are inviting guests to follow our journey of creating and establishing MCCS as the modular control center system. This journey and acting with this Checkpoint event started in 2021. And I can tell you from the first Checkpoint, we had a very small number of internal stakeholders where we have presented the progress of what we are doing in MCCS. And today, guys, look into the crowd. This has become a very, very big event with a lot of international and national TSOs, DSOs, research companies, and industrial partners, which is really cool, and we are very thrilled about that. But it's also important to say, as we are using this monumental hall, this is only possible with the support of our colleagues in a regional control center, RZ Mitte, who are enabling us and supporting us every year to using this very cool location, and for that, please, a big applause. Maybe some of you are following this Checkpoint events yearly, but I can tell you, this year there will also be something which is definitely new. Because this year, the Checkpoint event will be the first time where the Checkpoint is the kickoff for the Global System Operations Summit. The summit will be an interactive and workshop-alike conference program in the next 3 days, starting today until Friday. And we are really happy that we are able to organizing this program in close collaboration with the colleagues of the Global System Power Transformation Group. And also for that and for the strong collaboration with our colleagues in the GPST, big applause, please. And the ones of you who are joining the sessions, you can expect an amazing program because we are really thrilled because we have a lot of experts from different system operators, research companies, and industrial partners who are moderating the sessions and present the content and coming into the discussion with you. We at ELIA Group, 50 Hertz, ETB, the ELIA Transmission Belgium system operator, we are strongly believe at collaboration because this is a very fundamental aspect we are strongly believe in to push forward the digitalization of our energy system. And it is with the Checkpoint and the Summit event a kind of contribution to this collaboration today and in the next 3 days. Before we now jumping into the content of the Checkpoint event itself, it's a pleasure for me to introduce you our local and today's host of the Checkpoint event, our COO, Chief Operating Officer, Dr. Dirk Biermann, to the stage.
Yes, thank you, Mirko, and good afternoon and welcome to 50 Hertz. Welcome to Neuenhagen, that's the name of this place here. And of course, welcome to this year's Checkpoint. And thank you, Mirko, that you have basically said everything that I wanted to say. So let's see what is left from me here today. But the first point, of course, is that it is really amazing to stand here and to look at the crowd. It's amazing how many of you are here again this year, apparently following our activities, our project, and apparently interested in what we are doing. So thank you very much for your great interest. That is very much appreciated, of course. And then I look into very many well-known faces of dear colleagues, of friends, again, after last year's checkpoint. And of course, also this is nice, that we meet again and that again we have the opportunity to chat, to exchange ideas. And finally, I must say that I was really surprised when I looked at the guest list with the many countries on the guest list. So we have here among us colleagues from Singapore, from the Philippines, from the United States, I believe, from Colombia, from Chile. So it's really amazing. It's really surprising that people fly in from so far away. Of course, we have colleagues from many European countries, and of course, like Mirko said, from very many German companies and institutions, from TSOs, DSOs, but also vendors. I think vendors the first time in this checkpoint, and also from academia. So this is really, really great to see. And it is also great to see, like last year already, that the checkpoint is much broader than just a checkpoint. It's really, it has been evolving into an event that gives a place to exchange ideas, to discuss, and it's no longer just an internal event where we do a kind of project controlling or something like that. And that brings me to one reflection that I had beforehand. I was wondering, and this is now new for Mirko, so pay attention. I was wondering actually whether the name checkpoint is still the right one, because is it really a checkpoint? I believe that is much more than that, and checkpoint is really misleading. So if you have ideas there, happy for your feedback in the break or after the event here today, and then I can discuss with Mirko. But of course, Mirko and the team, they are clever. And they have already somehow reacted on my questions that I haven't raised yet. And you see the reaction, you see the answer, and that's the summit now, that you made the event broader. The checkpoint is maybe just the checkpoint, but the checkpoint is also now the kickoff of this broader conference on system operations. And that, of course, was, Mirko, congratulations to a team. Quite a smart move, also in my eyes. Yeah, and hopefully, of course, most of you can also then join the summit today after this event here in our headquarters, and then also tomorrow. I wish you very exciting and insightful discussions there. And now let's move to content. So where do we stand, and how will we take the software, the MCCS, into the control room? But to answer this question is not on me, but it is on the team. And so I just say thank you for coming, and let's have an interesting event here. Thank you.
Thank you very much, Dirk. And as Dirk said, let's coming to the content of the Checkpoint event. But before we are directly starting with the content, let me explain one thing which is very important for us. Very important for us as an MCCS team and crew. When we are in the Checkpoint, we are also illustrating what was the job and the task to do in the last year. And I can tell you the last year was for the complete team a very, very challenging year. Why? I mean, we are a big initiative, and we had also to learn that at some point we have to foster the foundation of the MCCS components to enable a much bigger scale. When talking about scale, I mean in the way of the amount of data we are able to integrate and to process within our system and also maintain the data, in the way of how we are making it possible to generate and update any kind of diagrams, and also in the way and in the speed we make it possible to integrate and orchestrate new components into the system. And some of you who have created or are actually creating software components, knowing the situation, when working on the foundation of an environment, this is quite often a kind of not that visible for the users in the direct sense. But on the other hand, you can imagine there is a big expectation that we are very fast in delivering components within MCCS. And it's a big thank you, which I want to giving back to the team today, that we have made this possible. Working on the foundations, working into the direction of the expectations we have with MCCS. And this was, in the last year, a lot of passion, a lot of energy of the team, but also sometimes a bit of headaches and even partly some tears which were necessary to come through this year and challenging all the situations we had in mind. And with that, dear guests, every big dream needs a brilliant team. Last but not least, and then we will start really to go into the content, which is very important. We are not a plain software development company. We are system operators, and from an operator perspective, we are creating software for operators. So it's also important for us to stay close with such presentations to our users and customers, because this is fundamental to understand the needs and the demands in all the control center situations we have in mind. And so for us, it's very important to have the collaboration with all the departments in system operations here in Neuenhagen, in system operations at 50 Hertz, but also with our colleagues on the Belgium side at ETB and our offshore colleagues, where we are working for the offshore-related features and functionalities. And so it's, for me today, quite a special honor, because I can now introduce you to amazing colleagues of the team who will moderate and facilitate you through the complete process of the first part of the presentations. And so please, a very warm welcome to Christiane Schiller, our product lead for monitoring and control. And the second one is Thees Stahl. And Thees is not only part of the operational team of system operations, he is also today the brave guy who will show you MCCS live on stage. So big applause for both. And with that, enjoy getting inspired, and the stage is yours.
Thank you, Mirko. And let's see how that goes. A warm welcome from our side as well. Not only to everybody who made it here to the beautiful and sunny Neuenhagen today, but also especially to the colleagues from 50 Hertz and from NCC in Belgium that are looking at us live, hopefully. As Mirko said, Christiane and me are not just standing here today by coincidence or just once. It's really something, it's in a collaboration that we've built up over more than a year now, and where we will see now a couple of steadily improving results. This is what we hope to bring you.
Central to our success is trust and collaboration between product development and our users, between the product owners and the system operators like Thees and I. MCCS is built in a modular, generic and flexible way with a solid foundation. This enables us to really tailor our solutions to the needs of our users and ensure that we future-proof our operational processes. So this collaboration allows us three things: prioritize what really matters, get early feedback, and quickly adapt and improve our product. So last checkpoint, we went into the pre-prod mode of our wind upscale in the control center. So let's see how this collaboration turned out. A happy birthday wind upscale from Max Siegel, who's the product owner, and Mike Michinski, a system operator.
Cake was good. So what Mike said, what my colleague Mike said, is it's not only important to have a tool that works and that has a functionality that works, but especially that the data that I see in this tool is fundamental to be able to trust the system and to be able to do my work as an operator. And that's why we've decided to make data a very first and very important part of this checkpoint today, and you will see in the next 20 minutes how we're getting data from the field into the system.
Yeah, and most of you will probably have one really prominent question in mind. How and when will we get more modules into the control room? Over the next 45 minutes, you will get exactly that insight. So you will see where we're currently at with our product development, and you will also see the next steps into further integration. But before we can put more and new modules into operation in the control center, first we need to commission MCCS to our data managers, because data is our fuel. Without it, nothing works. So only once data management is fully operational, we can truly unlock the full potential of MCCS in the control room. So now let me welcome Frederik Koppenberg, Sören Dittmann, and Noah Magel from Team Data to show us how this journey continues.
Thank you, Thijs and Christiane, for the very warm welcome. So before we take a closer look at our data strategy and also get more an insight in our data management software and also our architecture, we have a short video from Fai Tim, who is one of our operational data managers. Thank you. And as we heard from Veit, we have basically two challenges to tackle. On the one side, we have the topic of data management software that needs to be ready for the challenges of the future. And on the other hand, we have the topic of the initial data migration, modeling, and migration. So what does this mean? So actually, in today's system, we have configured close to 250,000 data points, 10,000 of assets, and a very complex topology that has grown over the last decades. So we've also find a lot of fun things into the data that we didn't expect while we migrate. So on the master data side, we have started with one substation, Yes Nord, last year to be able to have something for development purposes, and now we are starting to scale up, for example, to Region South with around 10 substations this year, and also supporting control zone-wide use cases for the area of voltage management or also grid calculations. At the same time, we are rolling out our new OT-IT gateway, which now gives us a real connection to the field. This is developed by our ecosystem of vendors, by Auco team, and we will complete the rollout until end of the year for the complete control zone. Again, simultaneously, we are also working on our data model. So our data model needs to be able to reflect everything that we need from our assets and also all the features we need for SCADA EMS software. The other thing that Veit mentioned is that we need to work on data management software that is ready for the challenges of the future. So alone at 50 Hertz, just to give one example, we will be adding 100 new bays every year for the next 8 years, and also a lot of complex assets, for example, STATCOMs, which will bring a lot of complexity and a lot of new data into the system. So we need to build up the software with these challenges in mind. So we need a lot of automation, data integration, reducing manual work while still being able to keep up the data quality for one of our most critical systems. And maybe just one remark, so this is work that we need to do anyhow, even if you would, for example, choose to take a software from an off-the-shelf, from an existing vendor. This is still something that we would need to do even if we wouldn't develop parts of our software ourselves. So before today, we thought about data is such a complex topic, or as Mirko always says, the data topics. And we thought about, okay, we have a complex data model, we have 250,000 data points, we cannot take you into all of this complexity. So we chose to follow the journey of a single data point today through the system. So we have selected a specific voltage measurement from a substation marker, and we will now follow the journey of this data point through the system from initial integration in the system until it is then ready to be used, for example, for monitoring purposes or for grid calculations. And with this, I hand over to you, Noah, to start guiding us through this journey.
Thank you, Freddy, for the introduction. So our data journey begins with our ELT service. Now, some of you might ask, what is the ELT service? MCCS is a new system, but we rely on data from our existing systems, which are already in use every day. And thank you. The illustration on the left shows what the ELT service does. So the ELT service automatically pulls data and integrates it into the MCCS data model. So on the left-hand side, you can see our source systems. In the middle, you can see the ELT service, and on the right-hand side, you can see the MCCS domain model. And this robot arm, the ELT service, basically extracts the data, as mentioned, loads it into our system, and then transforms it into the MCCS data model. And what this looks like for the user, you can see behind me. So this is a list of past ELT runs showing details like how much data was imported and whether or not any errors have occurred that need to be manually corrected. This is an extremely complex process because the data that we're working with has grown over 50 years and contains tens of thousands of data points. So sometimes transformation errors occur that need to be manually corrected. And this is where our versioning approach really helps. The master data system uses a data branching system similar to how software developers manage their code. And what this basically means is that changes can be made in separate branches that you can see on the illustration here. And changes can be made in separate branches without affecting the live data. So data first enters our systems from the ELT service and initially goes onto the integration branch. Once the data is reviewed, the changes can be merged into the main branch for further work. Perfect. So now that we have imported new data into our system, we need to compare it with the existing data and see what the changes are. And for that, Thijs will show us the diff viewer. So this tool is like a before and after snapshot that helps our data managers quickly spot issues and see if anything needs to be corrected. So on the screen, you can see the data point that we're following along this data journey, which is our voltage measurement, where the telecontrol address has been changed. And on the left-hand side, you can see the old data. On the right-hand side, you can see the new data. And highlighted in orange is the change. And then we also have this little toggle here to only show changes, which makes it much easier to see what's going on. Perfect. So this looks good. Now that we've confirmed that the data is correct, we can check this data point out in our MDS editor. So in this view, data managers can make additional changes. And as you can see, the editor provides a clean table-like interface that makes it easy to fix anything manual should it be needed. All right, so now we've covered how data comes into our system, how we review the data, and how we can perform any manual changes. But so far, we've only focused on master data. True value, however, is only created through the combination of master data and movement data. And for that, I would like to hand it over to my colleague Sören.
Thank you, Noah. So what you can see here is an overview of our data architecture to structure a little bit what we've talked about so far and what's coming next. On the left side of the architecture, you can see, as Noah described, the master data coming into our system. But how do we now get our field data? On the right side of the architecture, you can see the producers and the consumers and also our grid sketched. The very first touch point that we from MCCS have with the field data is a currently productively used system called process interface on the very top of the architecture. This can be seen essentially as a kind of data collector that collects all the multiple different data sources. One option that we from MCCS have to communicate to this process interface is another system called OT-IT Gateway, which you can also see on the top left side of the architecture. This OT-IT Gateway retrieves the field data and then publishes it to the MCCS architecture. Additionally, the OT-IT Gateway can be seen for us from MCCS side as a kind of a bridge between the existing solutions and any kind of future development that we from MCCS have to cope with. But how do these systems work now exactly? For that, we have to call Arend, the product owner of the OT-IT Gateway and the process interface, and I actually mean we have to call him because both systems are operated in a highly secured environment. Arend, can you please tell us more about the journey of our voltage measurement through our architecture?
Hello Sören, welcome dear guest. And yes, I can show you how we provide the real-time data for MCCS. To illustrate this to you, let's take a look at our current SCADA system. In this view, you can see the voltage measurement as we receive it from the substation market via our process interface and also forwarded it via the OT-IT gateway to MCCS. The connections between the substation market and the process interface and between the process interface and the OT-IT gateway are still active. In the two logs next to the telecontrol address, we can see the current value of the voltage measurement. On the upper logging received from the substation and in the lower logging forwarded to MCCS. How to create a data point was shown earlier by master data. The voltage measurement is now received by the OT-IT gateway via an IEC 104 interface and mapped to the expected Kafka topic. How we received the value for the voltage measurement in MCCS can be seen in the following overview. In addition to the connection status, at the left side on the top, we can see on the right side the current value of the last 15 minutes for the selected voltage measurement in the graphical and tabular view. This value for the data point is now available to the entire MCCS family. The process interface and the OT-IT gateway are supplied by the vendor Aukoteam GmbH. With that, we are able to use existing know-how from other software suppliers and to involve software solutions that are not developed by 50Hertz itself. With this short overview how we receive really real-time data from the field, I hand over back to Sören.
Thank you very much, Arend. So now with the field data provided and the master data available, we from the real-time data team take over. Our goal is to provide reliable movement data to the rest of the MCCS family. The very first touch point that we have with the field data is the MCC Kafka enrichment service, which you can see in the middle of the architectures, jumping up and down. One of our team members regularly controls the incoming data streams so that we can ideally early detect any kind of data incidences and fastly react to them. What you can see here now on the top left side, of our monitoring dashboard is the incoming data stream. The field data is continuously provided and the master data is cyclically provided. Now, with both data streams available, what the MCC Kafka service does is it joins the two data streams together. And with that, we can also have a look at the final data point. Thijs, if you would be so kind to share our real-time data analysis. What you see here now is the history of our voltage measurement point, and it's actually at the end of the journey through our data architecture and readily available for any kind of consumption for the other MCCS teams. Thank you very much.
So a big thank you to Freddy, Noah, Arend and Sören for showing us the journey of master data and movement data for one single data point through our 50Hertz grid. So if you're joining the summit tomorrow, you will see further insights into master data management, real-time data pipelines, and data modeling and governance.
Of course, we've seen the data point now coming in from the field into the system, but you've seen me at the end needing to use a specific MRID to be able to look at it. Of course, this is not a practical way to be working when we're really in operations. So what we'll have to do next is linking this MRID, this data point, that is still something abstract, to a real asset and to a real substation view, a real diagram, so that I can actually use it when I need to use it. And for that, in order to show you how that works, my colleague Benjamin Isenvodeki will come on stage. I will show you how the editor works.
Thank you very much, Thijs. So now, since the voltage measurement has been added to the master data system, Let us jump to the diagram editor. So the diagram editor is a central tool for data managers to create, maintain, and publish visualizations for the control center. Without the ability to do so, meaning maintaining the grid model in its visualizations, operating a SCADA system simply wouldn't be possible. But since the measurement value is added to the master data system, let's create a new diagram. Let's create market, Thijs.
Happy to do so.
So what happens when we create a new substation, in this case Marke, is that the diagram editor requests the master data from the master data system, and our generation algorithm interprets the CGMES profile, identifying logical elements like base and switch gears, and layouts them correctly. The final step then is to visualize this layout in a way that the data manager can see. So since we are talking about the voltage measurement, let's have a look of the voltage measurement in this display. So as you can see here, when we click on the measurement display, the right side panel opens and we have an overview of all measurements connected to this dedicated measurement display. And we can see the voltage measurement appearing here. Great. And I really want to highlight that. Generating a substation SLD meaning not only layouting, but really the linking of all master data to its dedicated assets. This is very helpful because it erases a lot of manual errors that could happen during the manual connecting of these I/O points. Automated generation is one point. The other point is the ability to manually create and enhance those SLDs. Because after the generation, this basically just offers as a foundation for further work. And for that, we aimed to implement intuitive handling of the editor, such as dragging and dropping symbols from the side panel on the left onto the canvas. The diagram automatically creates and draws connection lines once assets are placed on the canvas that are topologically connected to each other. And one of my personal highlights is the diff view. What the diff view does is that it compares the master data system with what is presented on the canvas currently. Meaning, if there's something missing that exists in the master data, but it's not on the canvas yet, it will show. It sounds difficult, but I think Thijs probably just show them how it works.
Showing it will probably be the best idea. So I'll just, for the purpose of this exercise, delete this circuit breaker here, and you'll see right away in this view that this circuit breaker appears. I can drag it back easily, and the links will be made automatically to where it belongs, so I cannot make mistakes.
Amazing. So now, since you have got a quick overview of the capabilities of the editor, I'm pretty sure you may ask, okay, what about scaling? So when can we create more than the few visualizations you have shown us before? And the answer is, the editor already has a lot of functionalities to create and maintain substation SLDs. The key enabler really is the quality-assured, consistent data foundation on which we then can create substation SLDs. Once this is clear, the creation of substation SLDs is very straightforward and growth will be exponential. Okay, now let me quickly summarize. So we have added a voltage measurement to the master data system. We can see it in the diagram, which basically is the world of the back office world of adding and handling master data system. The diagram part is basically slowly crossing the bridge towards the operational usage. So basically watching those created diagrams on an operator view. So let's just cross that bridge for a second and let's have a look how the visualization looks from an operational standpoint. Okay, beautiful. As you can see, it looks quite different to the one in the diagram editor itself. That means we have beautified it, we have manually enhanced the layout. But what we also can see, live data has been enriched, so we can see measurement values. And since we were talking about the voltage measurement itself, let's have a look at the voltage measurement. And we can see it on the top left corner, it is there. So, but it is not the only interaction we can do on this diagram. We could click on the measurement to get the measurement history of those specific values and look in the past to really see if there are any things happened in the past. Okay, the other interaction is clicking on the substation SLD. So I could drill down and open another substation by clicking on the dedicated text field. Substation view is one part of it. But of course, to really get an understanding of voltage management, we need to look on a more regional level and have a look on our control area. So let's zoom out a little bit. What we see here is our 50 Hertz control area on a geographical view. The nodes representing the substations, you can see the lines. And here we have the possibility now to enable the display of maximum voltage measurements. So let's do that as well. So for everyone who has been in the control center knows this is one way to view at it, but the more common view is the schematic grid view itself. We also did that. By the way, the schematic grid view has been completely created and maintained by the editor as well, which just shows as well how powerful this tool can be, or already is and will be in the future. So we have the geographical view, we have the schematic view, and also here we can interact. It's not just for visualization purposes only. So let's open a substation, for example. Let's open Lubmin from that grid view. Perfect. And from there, I can, as an operator, get more information or do controls. Basically, just to summarize here is we have two different ways of displaying the grid view, geographically, schematic, and depending on the needs, we can, meaning having a technical abstraction of the grid view or a geographical context, which will help to observe the grid in real time and identify bottlenecks, voltage drops, of course, together with other tools like grid analysis. Thank you very much.
Thank you.
Thank you, Benjamin, for your insights into the diagram editor and for demonstrating how operators can use MCCS to really monitor our grid in real time. But the work of our operators goes far beyond real-time supervision. They rely on static network security calculations, not only to ensure N-1 security, but also to assess upcoming situations and to calculate the possible consequences of their decisions. So this brings us kind of like to the magic triangle, the powerful combination of data, classic SCADA functionalities, and grid calculations. To take us deeper into the journey of how these pieces fit together and enable reliable system operation, I'd like to hand over to Michael Gerold and Dominik Wassermann from Grid Analysis.
Thank you, Christiane. Now, let's shed some light on the third part of the so-called magic triangle, grid analysis. And besides the methods, what is essential for every analysis? You might guess it right already, quality data. Because small discrepancies can already affect negatively the decision-making of our operators. The data quality has such a high price for us. That's why we follow a dual data approach. On the one side, we can work with CGMS files and thus integrate our systems to inventory platforms. On the other side, we can also use SIM-based MCCS data, which allows us to fast and flexible customize our data and thus improve the data throughout the process. Now, let's take a look at grid analysis in general. Both for real-time and for forecast analysis, it is important that we have robust grid models. This happens, what we already heard, by merging the master data with the measurement values. And now, let's focus on the real-time analysis track. This starts with the refinement of our grid models. This happens in the state estimation, which validates the measurements and replaces implausible data, and such creating a more complete and reliable network description. Next comes the network security calculation, and here we started with the contingency analysis, which evaluates how component failures may impact voltages and currents throughout the whole grid. So let's take a look at the software tiles.
Gladly.
This screen offers a direct and intuitive summary of the contingency analysis results. On the left side and the upper right side, we can see the currents and the voltages, both on the left side, on the second table side in the base case, and on the right side with the largest deviation based on the contingency analysis results. On the lower right side, we can see the voltage angles, which indicates if we can safely resynchronize the components after their failure. And soon, I promise you, there will be also a fourth table, which will show us the results of the cascading failures, which will help us to understand and anticipate possible chain reactions. This compact overview helps our operators to quickly assess the grid stability and also react to possible N-1 violations in real time. And now, I will hand over to Dominic, who will take a further look on the forecast analysis track.
Thank you, Michael. As some of you might have experienced, the landscape of system operations is changing drastically. Higher volatility of power production, fewer rotating masses, all lead to an increasingly more complex workload for our operators. In the product line grid analysis, we are developing a set of tools designed for clear and actionable decision support for our operators. One of the examples is volt control, which we're going to take a look at today. Volt control is a software we are developing in a joint effort between Elia and 50 Hertz. It shows the power and flexibility of our solution. 2 countries, 2 grids, a single solution. Now, Elia is all about stable voltages, as 50 Hertz is too. That's why we are developing volt control, which aims at providing the decision support to keep voltages in a secure level. For Elia, that means to operate the grid close to a target voltage. For 50 Hertz, it means to operate the grid in a range of acceptable voltages. But how does it work? Essentially, we start by using forecasted grid models from the day ahead and intraday processes. We then run a time-coupled AC optimal power flow and determine the optimal actions for our operators to take in order to maintain the voltages. But let's take a look at the software itself. I brought you here today a voltage profile from the Belgian power grid from the beginning of this year, a selection of certain substations. As you can see, we have quite a large peak in the morning hours between 7 and 9, and a small dip in the evening hours. If we now turn on the optimized voltage profiles, we can see clearly that our optimization has done what it should. It flattened the volatility and the peaks, and we are operating much closer to the target voltage of 405 kilovolts. Now, these voltage profiles, they're based on a set of actions, so maybe let's take a look at those as well. We have certain degrees of freedom in our optimization, for instance, generator reactive power set points, but also transformer taps and shunt reactor switchings. Let's filter on those who actually experience a change during the day. As you can see, we provide a complete time series of transformer taps to be implemented by our operators. The same counts for the shunt reactors. We provide the states for each hour which the operators can implement. But how that actually is going to look like from MCCS switching will be presented by my colleague and product owner of control, Malte Schaaf.
Thanks, Dominic. I think it's time for action. As Dominic mentioned, system operators are, among many other things, responsible for managing voltages in the grid. And to bring this closer to you, let's imagine the following scenario. So it's a lovely, quiet Sunday afternoon. The factories are idle, the offices are closed, and the households are only running on their usual appliances. Our transmission grid runs across the control area, but pretty much empty of load. And with little power flowing, the capacitive effects of the power lines tends to dominate, and that's exactly what's bringing the voltages upwards. Let's now assume that our tools that we've just seen, like volt control, for example, have already suggested appropriate countermeasures, and our operators use the control interface in order to switch shunt compensators, adjust tap changers, or generator set points. However, in order to fully stabilize the grid, one more measure is necessary, and the control center has decided concretely to turn off one of our transmission lines for the purpose of voltage management, and that's exactly what we will do together now. Before we start, I have to make one important disclaimer, and that is we are not switching here in our grid this time, but we are instead using an IEC 104 protocol simulator that takes commands, provides feedback indications, so we can demonstrate control capabilities. And now, let's jump into the system, Thijs. I can explain what we see here. On the right-hand side, we have, or we will see most of the control action that Thijs will make, and here we have the station of Lauchstädt. On the left-hand side, we have what we call the operational protocol that tracks every activity in the grid and thereby also the switching operations. And we have the schematic grid view that was presented by Benjamin already, zoomed into this respective area in order to keep the overview. And now, Thijs, I give you the order to please turn off the transmission line 380 kV from Jessen-Nord to this station here, to Lauchstädt, number 499, for the purpose of voltage management.
Thank you, Malte. I will gladly do that. So what I will do first, of course, everybody who knows something about grid management, is I'm going to break the current with a circuit breaker before I can do anything else. And for that, I'm going to open the control dialog. And what you'll see here is a new dialog will switch on, will turn on. This is my control dialog, but this is not yet in an active state. What I have to do next is go into the control mode, and you'll see highlighted pretty clearly that a red frame comes around it. So now, as an operator, I know I am actually sending, or I'm potentially sending something to either the field, or in this case, to the simulator. Let's keep it there. So I'm going to switch this one off. What you will see now in the protocol is that a new line will arrive. A switching command is sent to the simulator, and I'm also getting a positive acknowledgement. Of course, I will always have to also have to open my disconnector, which I will do in a very similar way. So now at the station Lauchstädt, I'm ready, but you see that the line state is still green, because of course from the station Jessen-Nord, my line is still being energized. So I have to do the same thing at Jessen-Nord. I will switch the circuit breaker, and now if everything goes well, if my simulator wants to, he will turn or switch the line state. Voila, there we go. So now my line is turned off, but of course, again, to be on the safe side and to keep everything good, I will also open my disconnector, submit the command, and Malte, I have successfully disconnected the line.
Thank you, Thijs. I think you would make a great system operator. So in order to conclude, let me sum up what we as a team actually provide, because control is more than simply sending control commands, something that we already demonstrated 2 years ago when we opened a busbar disconnector here in Neuenhagen. But actually much more functionality is involved. So the first key thing that we provide is the control interface, also known as the control dialogues, and we've here seen the example of a disconnector and a circuit breaker. Second, we own what we call the command architecture, which involves the execution of control commands, automated sequences, and also the field protocol communication via, for example, the OT-IT gateway that was presented by Arend earlier. And third, we ensure that switching operations are safe by additional mechanisms such as switch fault protection, authorization, and preventing two operators from interfering with each other. And now that we fully stabilized the grid, Christiane, I think it's time to look into the bigger picture and see what the steps are we have to take before we can provide the software to our operators. Thanks.
Thanks, Malte. So, what have we seen so far? We've explored how master data is integrated and maintained. We've seen how field device data flows seamlessly into our product cluster. Single line diagrams were created by data managers to support our operators. grid analysis tools supported our operators with grid calculations and recommended actions. And last but not least, control functionalities empower our users to work safely and efficiently. I really want to highlight the unique value of having everything seamlessly connected into one unified system. So what are the next steps for bringing monitoring and control into the control room? As you've seen, data modeling, integration and maintenance still requires a substantial amount of work that needs to happen first. And our product owners have provided a demonstration of our current development status. And we've come a long way. But we still need to develop essential functionalities before parallel operations in the control center can be enabled. So for example, for grid monitoring, we need to provide more dashboards and detailed grid views, and also include quality flags from the field and in the system. For control, we need to be able to manually override signals or states. We have to set points, locks, and enable switch fault protection. And for grid analysis, like Michael said, we need to develop cascading contingency analysis and also short circuit analysis. But really, bringing a control center system into operations, this is only half the truth. So if you really think about it, so we talked about data and the software. But before a parallel run, we need to talk about operations. We need a concept for operations and an SLA that works for a parallel run. We also need a viable infrastructure solution to bring the software into the control center. We will need interfaces to our legacy systems, and we also need extensive testing. For example, simulating our control commands and also testing them in the fields. And last but not least, we also have to include our users more, bringing MCCS, for example, into the training for new operators. So for some of you, the first part might even feel a little bit boring, or as Mirko said, it might feel like the bread and butter. But we need this base so solid, and when it is, it's time to add the toppings. So it's not just our goal to build existing functionalities or only improving them, but enabling entirely new use cases, ones that we wanted and maybe needed for quite some time, but couldn't realize until now. So many of the functionalities you've seen today, they're highly relevant for other users as well. For example, our colleagues in the NCC or at OOC. So this strong foundation connects our data, tools, processes, and also people across different areas. So now let's move on and explore these three special topics, and they build directly onto the foundation you've just seen. To kick things off, a warm welcome from Offshore Operations. Hier are Sabrina Mönch und Benjamin Jasitz.
Thank you, Christiane, for the introduction. So as most of you in this room probably know, it is essential for every TSO to maintain a digital shift book, or Betriebstagebuch in German. In this shift book, a lot of data about certain actions and measures that are taken in the grid during operational business are documented. And one part of this documentation is the permit management process, so the coordination of scheduled outages between the control center and the field. This is necessary so that work on assets can take place safely. And this process involves a lot of people, starting in the control center, going through the regional centers, and ending in the field with the people who apply safety measures and perform the work on the assets. And right now, this whole process is spread across multiple different systems. Each party involved uses their own tools and works with their own data, which is crazy when you think about it. Everyone, so the control center, the offshore operations, the regional centers, and the work controllers only see their part of the process. Data has to be maintained redundantly, and coordination is super tricky because no one has the full picture. And this is where the MCCS changes everything. We provide one system for all parties involved. Everyone works with the same data, and the whole process chain is covered in one place. Sounds better, right? So what does it mean in practice? Let's take a look at the advantages. Benjamin, our colleague from the Offshore Operations Center, will now show you how the documentation of the scheduled outages will be done in the OOC, which, by the way, will also be our first customer using this part of the software in the beginning of next year when we start operating our first offshore platform in the Baltic Sea. So Benjamin, let's see it.
Thank you, Sabrina. In the permit management, we have 3 levels. The permission for further disposition from the CC to the OCC, the disposition permit, in German VE, from the OCC to the operation controller in the substation, and the execution permit, in German DE, from the operation controller to the work controller at the workplace. In the overview, we can see the whole process chain, so permissions and the dependence on each other. The control center, the operator OCC, and the operation controller all have the same view, work in the same system, and have access to the same data. The status shows whether a permit has been issued or returned, so everybody always has the full picture. In our example, we received an EWV from the control center. On the basis on this EWV, we would like to create a VE for the operation controller in the substation. Via the menu grant permit, we open the input mask. In the input mask, we enter the giver-receiver, the station area, and the state of the grid element. And here you can see a great advantage. We link our VE with the EWV. By clicking on the grant button, the permission appears in the overview and can no longer be edited. The VE number are linked to the EWV. To return a permission, all assigned permissions must be returned. If the EWV with active VE is to be returned, we get an error message. This is another advantage of seeing the whole process. We can now restrict the return of a VE before all linked DEs have been returned. This is important to guarantee the safety of all workers. We take back all execution permit when we can return the VE. So now we can return the EWV to the control center. With that, we have seen how a critical process for the offshore operations can function. Looking forward to using this in production.
Thank you very much, Benjamin. Looks like we are ready for the go-live of our offshore platform. Super exciting. What we just saw was only one part of the process chain. But in order for us to have a smooth and seamless process in which everybody works within the same system and, most importantly, with the same data, of course, the control center is the next customer that we will integrate into the solution. This will bring even more benefits and foster the collaboration between everybody. Thank you.
Thanks, Sabrina and Benjamin, for this brief look into offshore operations and the future connection with the control center. We talked a lot about voltage management today, but let's switch to a completely different, but I would say equally important topic, congestion management. It's one of the biggest and probably most expensive challenges of the energy transition for our grid. Over 3 billion euro a year for Germany alone. So let's welcome Nico Westerbeck from Team Topology Optimizer.
Thank you, Christiane. Indeed, congestion management is not only very expensive, it's also very challenging due to the complex time nature and the complex problems we have. So I today present to you the Topology Optimizer of MCCS. But that's not just any topology optimizer. In fact, I'm proud to say we are the first production topology optimizer that works on a full-scale grid without meaningful action set reductions. And this has been a thing that in research wasn't even imaginable just a few years ago. It was an unsolved research problem, how you put tens of thousands of switches into an optimization and get the results before you're 80 years old. So this problem, we solved it with quite a cunning trick. And now when Thijs goes into the control module and starts an optimization here, it looks like he's just pressing a button. In fact, he's just pressing a button. But in the background, something quite marvelous happens. Together with Tenet, we built a GPU-accelerated load flow solver that crunches through 1 billion load flows every second. So this load flow solver now, with 1 billion load flows every second, has the potential of crunching this action space, which is exponential and large, in under 10 minutes. So we are able to get topology optimization results in under 10 minutes. Why is this important? Well, this process, the congestion management process, has so tight time constraints. If this were to take 20 or 30 minutes, this would actually be a completely useless tool for us. And getting it down to this highlights a little bit how innovative technologies like GPU acceleration can actually get us there. Now, we don't have 3 minutes time on 10 minutes on stage, just have 4. So we prepared something for you. On the 11th of June this year, we had a congestion on the Berlin diagonal. So we had problems which overloaded the lines. And the operators, they have topologies that they can use from their experience. But we ran our optimizer. And our optimizer actually came up with a quite cunning plan. It switched a Reuter, which is on the Berlin diagonal, completely open, opening the Berlin diagonal, making it like 2 ends that don't meet. And our operator, Sören, who would be on stage with me today, unfortunately he's sick, so I have to cover in for him. He looked at the topology and thought, wow, it's actually interesting, something I haven't thought about, and something that evolves and improves upon his ability to do topology optimization himself. So looking at this topology with the split, he came up with the point, oh, that's actually pretty cool. He talked to his colleagues. They also said, well, it's an interesting solution. And voila, they have a new tool in their chain of doing topology optimization. And this type of interaction between innovative, cutting-edge technologies and humans is exactly what our topology solution is about. And now, I hope you're very curious, because tomorrow there'll actually be a whole day dedicated to topology optimization. If you come to the NQT, you can see all about it, not just us. Basically, everybody who works in the field will come. So at first, a warm invite for you to come there. Second, this journey that we are taking is certainly not over. So what you see now is the first version that brought the first results. I will take you later, tomorrow, on the journey of how we can get to a full working, always working version, because we still, to be honest, have problems with voltage constraints and with data issues. This event is about data. That is the journey that will still be in front of us. But I hope we don't do the journey alone, because this tool will be available to you as an open source tool. We are in the final steps of getting this thing as an open source tool. So you, if you have a grid or happen to know somebody who has a grid, you can try it. And if you like it, I very much invite you to collaborate and to build the best topology optimizer of the future together. And with that, time back.
So I promised you 3 special topics, so we have one more before the break. The last one will be, I would say, in harsh contrast to the daily operational business we showed in all our previous demonstrations. So let's welcome Cornelius Heck and Michael Gerold with a more exceptional situation.
Thank you, Christiane. What Christiane didn't say, I am a magician. I can look into all of your heads. I know what you're thinking. I hate blackouts, right? This is what you think. And so do I. Nonetheless, we've had 4 blackouts in Europe this year alone. They all had one thing in common as well. They were only temporary, because the operators knew how to restart their grids. Grid restoration is trained on a nearly daily basis. Just today, we had one grid restoration test in 50 Hertz as well. But there's going to be a change in the future. So far, grid restoration has always worked with having one gas-fired power plant, ramping voltage up, and then connecting other synchronous generators. In the future, we are going to have power electronics. So that is wind, PV, battery energy storage. And you can train all you want. If you don't understand the fundamentals of the system, it won't work. So we need to think about how can we assist our operators with simulations. And to do so, we started with a proof of concept today to just not have dynamic security assessment in an old-fashioned RMS way, but looking into a more detailed electromagnetic transients way. And Thijs, will you be my DJ and assist me in this case?
Happy to do so.
So we are going to run 2 simulations today. And as you can already see by the simulation names, one is going to be stable and one is unstable. So what's the difference in these scenarios? I will tell you right after you have started the simulation.
Already done.
So in the first simulation, we will have one battery energy storage to restart our system, and then we will try to connect a wind park. Might be stable, might not be stable. Let's see. In the second scenario, we will have the same battery, restart the system, but then connect the STATCOM first, and then connect the wind farm. So this is basically the very simple scenario, which is close to what we'll see in 50 Hertz in just a few years. So Thijs, I think we are already done. What we are going to see is 20 seconds of simulation, and as you just saw, we are faster than real time with our simulation, although we are running microsecond time frame simulations here. So looking at the results, please show us the first simulation results. And looking at the voltages, which is the second plot here, you can see the ramp up of the voltage looks fine, then it stays stable, and then there's some form of wiggling going on there. I'm not sure if that's stable or not. If it's not stable, we might need to look at the active power as well. Okay, the active power seems to have even more oscillations going on there, so probably not stable, but who am I to tell? I don't have any experience on dynamic security stuff, so let's look at the very first graph here. And what it shows, over the period of these 20 seconds for each and every device, is it switched off, is it switched on, and is it unstable? And this watchdog, which watches every device in our simulation, can also be installed on this device and also measure each device in the field. So this is quite impressive, I would say, to have this reuse aspect in this case as well. So nonetheless, Thijs, this doesn't look stable. We've made a mistake. Connecting wing part to the battery wasn't a good idea. But luckily, we'll also have STATCOM ready. And looking at the voltages, looking at the active power, fine. We don't have any oscillations there. And also our watchdog says everything's fine. This is how we can restart our grid. So let's do that. Thank you very much, Thijs. Michael, you're going to talk us through the whole process behind this proof of concept.
That's right. Thank you, Cornelius. Now I want to share with you the story behind this development process. So besides this exciting results that we have seen, this proof of concept also should showcase how straightforward the integration of third-party solutions within the MCCS environment is. And for that, our software partner Avasition provided us with a container version of their EMT DSA solution via Vento. Establishing a solid data contract was just the first part of this process. Afterwards, it took us 8 weeks to build this proof of concept. And from our side, it only took us 2 part-time developers. Now you might ask, how was this possible? By reusing 40% of our back-end components and, now please listen, 100% of our front-end components. That's why these screens might already look some kind of familiar to you. Due to these shared components, the integration of third-party solutions seems seamless. And so also the user experience remains consistent through all the MCCS tools. Our approach not only simplifies the integration of third-party solutions, but also ensures that everything feels and operates like a single product. And now after showcasing all these MCCS tools and all the capabilities of MCCS, I want to hand over to Anne-Kathrin Martin, our Head of System Operations Management.
Thank you so much, Michael. And also a warm welcome from my side. Thanks for taking the journey to Neuenhagen. I know it's not easy from downtown Berlin. We know it very, very well. So thanks a lot and a warm welcome. Even though I'm into all the details, not all the details, but briefly the results of the team that you are creating throughout the entire year, every year I'm standing here being very overwhelmed of all the results that we see, even it was just very high level, and it was just a part of the results. It's a kind of overwhelming. Well, but I assume it's not a surprise to all of you, and the facts are very, very well known by Dirk and Stefan. This doesn't come for free. It costs a lot of money, a big workforce. You saw some of the developers on the screens in the beginning of the checkpoint. And so I receive the question very often, why do you do it by your own from scratch? Especially the monitoring and control. It's, as Mirko always says, bread and butter. So go to the supermarket and just buy bread and butter. The answer is twofold. One thing was already answered by Freddy, your team, and also by Christiane later on, earlier on. It was the topic of data, what it's all about today. The data integration would be more or less the same effort if we would buy it from the market. So no difference. How do you call it? 75%, this is what I mean. 75% of the effort that we need to spend in MCCS to make it running would have been the same effort that we would need if we buy a product from the market. Point one. Point two, not less important, and this is why I have a bag today. If you buy a product from the market, it means it's a so-called monolith. What does it mean? Well, the vendor from the market doesn't want you to access all the data points because it's his product, it's perfectly fine, shiny, works well for the operators, but he doesn't want you to really, go into the data points and use it for whatever. And I just stole some toys from my daughter's toy box this morning. Great ball. She loves this ball. I hope she didn't realize yet that I have it. Works perfectly fine, but I think it's not a secret. It's just a ball. You cannot make a car out of it, or an elephant, or something. But there are other toys. Danish product, all of you know it. Luckily, she's only 2 years old, so the brick is a little bigger than the bricks you know. Lego bricks. Perfect tool. You can make a car, you can make an elephant, you can make a house. Very adaptable, because Lego wants you not to just build a house. Lego wants you to be creative. And I even made a heart for MCCS. So even this is possible with Lego bricks. And the Lego brick is just a picture, right? The Lego brick is just a picture for a product that you create by yourself. It's on our hands to create interfaces to make it possible to access all the data points that we want, not just for monitoring and control, not just for fancy things like EMT simulations for DSA purposes, not just for volt control, for everything that we need today, we need in the future, and we also need in 15 years. And this is the second reason why we are doing it by our own and not just buying it from the market. Thank you so much. I think I have the honor to tell you it's coffee break. So thanks a lot for the first part, being so interested. I think it's presented outside where you also found the lunch. And see you back here in 10, 15 minutes?
There will be a countdown again.
Roundabout, between 10 and 15 minutes. Thank you.
music was a bit long. I think they want me to dance, but I'm not going to do that. Welcome back. We will start now with a very exciting part of the checkpoint. The first part was the inside out. We showed what we did. And the second part is we look around what is happening around the world and the ecosystem. Before we start that, let me give you a brief background. We are a transmission system operator, so we plan, build, operate, and maintain the transmission grid, which is traditionally hardware, the physical world. But our world today, it's not just physical anymore, it's also digital. Therefore, we are also building we're planning, building, operating, and maintaining the digital infrastructure with this software. So we have a new identity in a way. We are the guardians of the grid, but we are also an active contributor to the digital ecosystem. And this is very important because, let's be honest, in 5 years, do you think we need less software or more software? We probably need more software. And in 5 years, do we want our organization, or do you want your organization to be more dependent on externals about this knowledge, or less and more independent? I think you want to be more independent. So the main point here is that we need to be more digitally mature. And what I want to say is MCCS is much more than just software for the control center. MCCS is building internally this skill and the deep knowledge about software and how it interacts with system operation, so you can actively contribute to that system. We saw it today, data models, automation, visualization, AI. So we have this deep knowledge here of the colleagues that you saw before. That was a long transformation process. Now, why do I mention this, and how is this connected to the session that we have now? When we look around the world, we have many different, we have a bit of a problem here with the slides, but so when we look around, we see system operators, distribution operators, researchers, all kinds of actors in the ecosystem. They are also developing software. So we are not alone, and you are doing this exactly because of that, because you, when we look at Transnet BW, for instance, at TenneT, at Energinet, at Singapore Power, we had a meeting with the TSO of Peru, and the CEO asked me, what language do you use for coding? So that was quite interesting. And they all do this because they want to build internally the skills and the know-how as well as the software. What we do now in this session is, once I will fix afterwards the slide deck, is we will go here. We will have a bit of a view into what is NSOE saying about this whole thing. We have a bit of a view into the ecosystem, what is happening in Thüringen, in Ireland, in Singapore, in France, and then the very important questions, how can we cooperate? And open source may be a very effective tool to do this, so that we can reach an ecosystem that looks like that, not a static ecosystem, but an ecosystem where we can all contribute together, where you don't have just a few suppliers, but you have a living ecosystem. So let's start with the first spotlight. I would like to ask Morten from Statnett from Norway on the stage. And we recently, NSOE, published a paper on the vendor agnostic solutions. We have Anna as she left us a video message, and she will give us a video message, and then Morten will explain a bit to us what the NSOE paper is on the vendor agnostic solution.
Dear MCCS team and MCCS Checkpoint guests, hello. I would like to send you my best greetings from Poland, where I am at the moment, and I regret that I missed the opportunity to join you for this fine event, MCCS Checkpoint. At the same time, I'm attending a scientific conference, and that's why I can't be there with you. Apologies. My name is Anna. On a regular basis, I work for Polish TSO, which is PSE, and actually I work for a daughter company of Polish transmission system operator. This is the company called PSE Innovations, and we deal with all research, development, and innovations activities for our mother company. At the NSOE level, I play a role of a convener of one of the working groups under Research, Development, and Innovations Committee. This is the working group 5, and our scope is digital and communication. Via this video, I would like to emphasize how vendor-agnostic solutions are important for European TSOs gather and working together in the NSOE. In Working Group 5, we deal with all different digital technologies such as AI, digital twin, wide area monitoring systems. And during our work, we have realized how important the fourth of our work streams, namely vendor-agnostic solutions, is for all the other activities. This creates, this vendor-agnostic solutions approach creates a common denominator for all other activities. The vision of this new ecosystem of solutions that are modular, standardized, transparent, and they provide the highest standards for cyber and digital resilience. This vision has been officially approved by Research Development and Innovations Committee, and now it is a public vision of NSOE. It is covered within a dedicated so-called position paper. The position paper is directly available at the NSOE website, so you can simply Google it. During the MCCS Checkpoint event, Morten from Statnet, we also introduced some details from the position paper. As Task Force Vendor-Agnostic Solutions, we have received also support from external stakeholders that would like to cooperate with us on fine-tuning this vision, providing technical details to support this next generation of control systems. And MCCS is an excellent example of implementation of this vision. And I would like to clearly say that it's not just a vision anymore. The system is running and operating, and during the MCCS checkpoint, you will have a chance to see that running. I'm wishing you a great event, a great time of being there together, of exchanging expertise, all the discussions, and simply enjoy the time and have fun. All the best, and I'm looking forward to meeting you soon. Bye-bye.
Thank you, Anna. It's not just yet in running, but she mentioned that just as a disclaimer. Morten.
Okay. Thank you for the invitation. I've been part of this vendor-agnostic solutions group for the last 3 years, maybe 4 years. And it's interesting to see when we came together as a group 3 or 4 years ago, we started to discuss the different challenges we have as TSOs. And we were discussing what should be the scope of this group and so on. And quite fast it converged to say that we all had different challenges, but it all came back to that but all had we came from one single vendor for the control rooms. We tend to give a vendor contact saying that you are responsible for the solution and all that kind of stuff. And then we started to work on this paper and see what do we need as a TSO for the future, because it's more or less everyone said that, okay, what's new? The new now is that we, as you show up here, we come from a static wall, but the new world is, change is the new world. We need to change both to cope with the new power system, but we also look at the cyber threats as well. We need to change things, patch things, everything. Then we need to rethink the whole way of building software. And as I said, no single provider can provide all the required functionality we need for the control room. We don't say that we don't need providers, but we need more providers, and we need an ecosystem to cooperate. That's why we've been working together on this paper. It was, as Anna mentioned, it's downloadable for the NSOE website. It was published in June. We also had a first touch with vendors. We have presented it for the vendors. So, but to summarize the paper, it's built up around 7 tenets: transparency, modularity, standardization, integration, digital and cyber resilience, separation of concerns, and new ways of working. Some of you might have been around in this business for a long time. This is not new, all of it. Maybe some of you are aware of, in 2011, Sigrid published a paper called Architecture for the 21st Century for the Control Rooms. I think more of these a few of these tenets you see on the screen here was also part of that paper. But why didn't we succeed with that? I think one difference from that paper and what we have published now is probably number 7, new ways of working. Because what we did in 2011, we wrote that paper and we gave it to the vendors and we said, build this architecture. We just still gave one vendor. We need to rethink how we are working with in an ecosystem. You need to look at more vendors, different ways of cooperating, open source, collaboration between DSOs, TSOs, and so on. So, yeah, so the paper is setting a kind of a North Star for how we as TSOs in Europe want to build software for the control rooms for the future. So, yeah.
Morten?
Yeah.
So, applause, yeah? Thanks very much. The why of the NSOA, no single provider can provide all required functionalities. And now we go to the what. We look a bit into the ecosystem, what is happening around the world. And for this, I would like to invite Charlie Smith, who traveled all the way from the East Coast of the USA. And Charlie is leading the GPST and the ASIC group, and he will moderate this session. So I will hand over to you to moderate the session where we get an inside-out view from around the world.
Thank you, Arya. It's a great pleasure to be with you here at the 50 Hertz Checkpoint, representing both the GPST and the ESIG. A number of people walked up to me this morning and said, I think I've seen you before on a webinar someplace. I've moderated a lot of webinars, especially during COVID, so I'm sure I've met many of you, and it's a great pleasure to see you in person here today. It's also a great pleasure to be working with you and 50 Hertz, Arya, because as a member of both organizations, ESIG and GPST, I've had a chance to get to know you all a lot better, and the leadership that you're providing on the MCCS and the control room of the future is really outstanding. I've had conversations with many system operators over the last 2 years about the increasing need for a more agile response to the control room needs of the future, and I think you're truly leading the way, and I congratulate you for that. So let's move ahead with the session, which will briefly seek the input from 3 sectors of the ecosystem: system operators, industry, and academia. And let's begin with some system operators. So first, let me introduce Krzysztof Brzezinski from Thuringen Energienetz. Krzysztof, TEN is a DSO in Thuringen. I hope I got that pronunciation pretty good.
You got it quite good. Thank you.
You provide millions of people and the German economy with energy, and as critical infrastructure, TEN takes digitalization seriously, and you're currently in the process of setting up a new department.
Yeah, that's
so,
right.
In terms of digitalization and transformation, what is your organization doing to address the challenges of the energy transition, and how do you see the benefit of cooperation?
Thank you, Charlie. That's an interesting question. At TEN, Thuringen DSO, we see the energy transition and digitalization as two sides of the same coin. The challenges are clear. We are integrating more and more generation and decentralized energy systems, and also the customers expect new services. At the same time, we have to guarantee stability and security of supply, which is the foundation of functioning the economy in Thuringia with approximately 2 million people living there. To address this, we are currently setting up a new digital department, and this is not just an IT initiative, but a strategic step towards shaping our future. Here I often think about Conway's Law, which says that organizations design systems that mirrors their communication structures. So if we want to design flexible, user-oriented digital platforms, then our own organization must also be flexible and collaborative. That's why we are building this department with cross-functional teams, strong ties to operations, and clear interfaces. We are already having a good example of how this approach works: the successful implementation of Redispatch 2.0. This was a complex nationwide requirement that fundamentally changed how grid operators coordinate congestion management, and we successfully implemented it within the last few weeks. We finished the project. So it required new digital processes, but also close cooperation between departments and external and internal stakeholders. For us, it provided that then technology and organization go hand in hand, and we can deliver reliability if we do so. At the same time, we know that cooperation is absolutely essential also for the energy transition in a whole ecosystem. No single grid operator can solve these challenges alone. So that's why we are, for example, working on a workshop format with MCCS members to collaborate and to exchange best practices and lessons learned in the future. This kind of collaboration helps us to accelerate our learning, avoid mistakes others might have already solved, and develop solutions that are scalable across the energy sector. So when we speak about digitalization at TEN, it's not about technology, it's about creating a new organization and a working model. So put it in one sentence, digitalization is not the goal itself. In this way, we empower people, organizations, and technology together to work towards a successful energy transition. Thank you, Charlie, for having me on stage.
Thank you, Christoph. Okay, next, let me introduce TJ Davitt from AirGrid. TJ. Hi, TJ. Grab it. Yeah.
Okay, first, thanks very much for having me.
Let me just say that TJ has had some interesting developments at AirGrid, including discussions with the regulator. And in terms of digitalization and transformation, TJ, let me ask you, what is AirGrid doing to address the challenges of the energy transition, and how do you see the benefits of cooperation?
So I guess if I start with the regulator, right, so we've had the opportunity just recently to lay out our 5-year strategy. So our funding is generally speaking on a 5-year recurring cycle. So we've been working very hard to lay out our IT strategy, all of the types of products that we're going to need to do. So we focus very much on technology resilience, how do we keep our systems scalable and secure. We focused on digital transformation, so how we can get the right data flow, how we can give our customers the right information that they'll need. And we've looked at our need to standardize or deliver our offshore wind capabilities, and working on our whole of system solutioning, right? So very much to date, we haven't been engaging deeply with the DSOs in Ireland, so there has been interaction, but we're not sharing data in a real-time kind of manner. And what we've worked with the regulator on is making sure that their vision and our ultimate goal of getting to 80% renewables by 2030 is achievable. We've laid out kind of the applications and the technologies that we'll need to do that, and we've worked deeply with them to show that that's the tip of the iceberg. So the end state that they'll see is the tip of the iceberg, but underneath that is a common set of foundational services and platforms that we'll need to make sure we can get the right data to the right people at the right time, so that they have the situational awareness to make those key decisions that they need. So very much like others will have talked through. In terms of digital transformation and what it kind of means for AirGrid, so we have a couple of major pillars, right? So one is our overall digitalization strategy. We'll then also have kind of leaning into AI and machine learning and data analytics like everyone else is doing. But one of our key topics will be decoupling, which is kind of how we came to MCCS and what we might look to do. So very similar to everyone else, we've challenges where we have a couple of key vendors, right, or real core centers of gravity within AirGrid. So what you'll see on the left is kind of represented as us being kind of a tanker or a shipping container, where we don't have much mobility or agility. We have 2 big centers of gravity in our energy management system and our market management system. And traditionally, all new functionality has gone into one or the other of those platforms. And there are peripheral systems, but generally speaking, it's point-to-point integrations in between them. And we have worked ourselves into some situations where, you know, we might be the only vendor on a given platform, which represents operational risk there as well. So we've looked at where we are. We've also then looked at our future state, or our North Star of where we want to be, right? And that's, as you'll see kind of on the right, that we have a set of foundational services. So very much data integration, having an enterprise data model for a common representation of data across the business, the right data and application integration tools, that we have the right observability across that. So right now we have a challenge where oftentimes we can't quite see where an issue might be over a wider IT landscape. So we're looking to put in place a set of foundational services over time that will allow us to kind of plug and play, bring in additional vendors to the ecosystem to put more competitive tension or competitive pressure on those core vendors. We're starting to work to assess where we're bringing in new technology. Should it or could it go into those core vendors? Can we develop it ourselves? Or if not with ourselves, can we develop it with partners and give ourselves more freedom and more agility? And what you'll see in the middle is very much the first of our transition architecture. So we know we're not going to go from left to right. There's going to be a series of phases as we bring different platforms and different services on board. So we're looking to do that in a way that will kind of deliver consistent business value and then enable more reuse as we move from left to right. So it's going to be a major program of work for us, our big challenge. So thanks to the successful interactions we've had with the regulator, we'll move from a situation where really we didn't have the funding to go on these situations to a case where the regulator now is very accepting of what we need to do. They've agreed to make the vast majority of our funding available, so our challenge now becomes a delivery challenge. So we really have an opportunity now to stop with the ideation, the business cases, and the design iterations, and get cracking on developing these platforms of the future and bringing value ultimately to Ireland as a country.
Sounds like you got a big job ahead of you.
Absolutely.
Thank you.
Yeah, thank you.
Okay, next, let me introduce Kevin Koh from Singapore Power Group. Yes. So Kevin, Singapore Power is an electricity and gas distribution company, and recently you published a paper together with your regulator, EMA, in which you provide a roadmap to Singapore's future grid capabilities. So in terms of digitalization and transformation, what is Singapore Power doing to address the challenges of the energy transition, and how do you see the benefit of cooperation?
I think one of the key challenges that we're looking at is that Singapore currently has is really relying on natural gas, but in the next 5-10 years, we are moving towards a more greener, sustainable energy source. And the challenge is that we're also growing the grid massively in the next 5 years, right? Energy demand has grown from an average of 2% to 3 to 5% in the next 5 years. That also means that the capex investments that we need to put into the grid is going to increase, will be accelerating in the next 5 years as well. For us, the grid is just going to get more and more complex, right, in the next 5 to 10 years. Obviously, because of EVs coming in, government has announced that by 2030, there will be no more ICE vehicles being sold in the market, means everyone's go EV. And today, the trend is already accelerating. We see that 1 in 2 cars sold every day, every month is an EV, right? So I think we are accelerating on that journey. Solar energy is coming in as well, and we're doing interconnects with the neighboring countries. So we have a goal of getting to net zero in 2050, and that's going to be a quite ambitious plan. And that means the energy transition is going to be very accelerating in the next couple of decades, right? And so these are the challenges that we are facing today. And what that means is that we've got to rely on digitalization to meet our sustainability and energy transition goals. And one of the things that we are doing is really exploring new models. One of the early models that we are piloting this year is virtual power plant. And it comes with its own challenges, right? Because VPP itself is market-driven, and that means that it might also bring, and with our role to ensure grid stability, we've got to balance what the market is doing versus what the grid is doing, and to ensure grid stability. And so one of the things that we're going to do is to really look at how software or technology can help to balance the needs, right, and orchestrate between a VPP and the DERMS that will ensure grid stability, and look at network congestion and see how we can balance and maintain grid stability at the end of the day. And so we're going to invest quite a bit of our technology into figuring out how to balance and orchestrate the two, right? The other areas that we're looking at is also looking at digitalization of the work processes. As you can see on the we have created SP Digital as a separate unit. So I head the SP Digital unit in the SP Group. And what we have done in the last 9 years is to digitalize the processes that are done by the digital field workers. We've introduced the smart grid solutions as well to really get the data from our asset and building a digital twin so that we can plan better and forecast our energy needs and our asset renewal plans in a more efficient and using AI to drive a more optimization of the network in terms of our planning and the renewal strategies, right? So that has been a challenge that we have been grappling with, and that's something that technology can solve it. And when we look at the future, a lot of the challenges that we have can be really solved with technology, software solutions out there. And I'm very glad to be part of this event because I'm here also to find out what other grid operators are really using technology in terms of how do we advance our energy transition in the next couple of years. How do we use technology to enable that, right? We are already having, and of course the next wave beyond digitalization is really look at how AI can help us, automate and accelerate and even help us in the journey towards energy transition. So I see this as a very important forum, and I think collaboration between utilities is going to be very critical. Because in Singapore, we only have one utility, right? And how do we learn from each other? How do we know what others are doing, right? And that's why these forums like this is going to be very useful to know how we can share notes with each other and to figure out how we can use technology to help us achieve our goals in terms of energy transition. Yeah.
Thank you, Kevin. Another very ambitious program. Okay, switching to industry. Let me introduce Luc Philippot from NetSeller. Luc, welcome. I understand that NetSeller is a company that is developing software for the energy sector and control center systems, and you've been working at NetSeller for 23 years, and before that, for 6 years with Siemens here in Berlin. So I'd like to ask, how do you see the shift from closed monolithic systems to open modular systems? And what impact does it have on the market with regard to the participation of smaller software companies? And what are the challenges and opportunities that you see in front of us?
Thank you for that great question. So my company has been developing monitoring software for 25 years in different areas, as you can see here. And I was always thinking that monitoring would be part of the control system one day, and it just never happened. And so we had to build everything by ourselves. We know about the master data, also real-time data. Everything needs to be done. And also, every few years, you need to do some deep refactoring of the software. Although through 15 projects or so, this has been growing and becoming a big, that ugly monolithic thing, sitting kind of at the same level as a SCADA EMS. And so we started thinking we can't do it this way anymore, and we have to go to a modular design. And we started thinking how to do modules, for example, centered on a particular type of data, like, disturbance records, or permits, as we have seen before in the previous presentation. That's a kind of data object you can focus on. Or a module can be focused upon a service, like, for example, providing suggestions to the operator in case of unsuccessful auto-reclosing. So that's a completely new way of thinking. And I think we would like definitely to focus on this kind of contribution. We just had no platform to work with. Or eventually the big SCADA manufacturers would propose to do so, but based on their own platform, which means another closed system again. So I'm really very excited by this MCCS initiative, and I hope that through this ENSOE contribution with the vendor agnostic solution, this idea is going to be more widespread in the future. So I think that the market is opening to more players, like my company and many others, who will be able to actually focus on their core contribution to build the system altogether. Of course, I see some hurdles here, because the good thing with a closed system is that you know what you have, you can test it, you can deploy it in a very controlled way, and the responsibility is very clear. If I deliver a module, I must be very, very careful about the inputs, the outputs, also the migration concept from an early prototype until a full working solution. So I think there are some new challenges, but I'm very excited by this market shift that makes it possible, in principle at least, for many companies to contribute and to go faster to the market and also address the flexibility that is much needed for the energy transition. That's my point of view. Thank you.
Thanks, Luke. Okay, and now switching to academia, let me introduce Luigi Vanfredi from Rensselaer Polytechnic Institute. By way of introduction, let me mention the ILIA 50 Hertz Research Challenge for the Control Room of the Future, which Luigi happens to be working on, and its relationship to the larger GPST research agenda. We'll be discussing both in more detail over the next 2 days, with the 50 Hertz Research Challenge during a regular session tomorrow, Thursday, and then the GPST Research Agenda and a special session on Friday morning. Luigi, you're a professor at Rensselaer Polytech in New York. Great university. You have 20 years of experience in research and development in academia and industry. How do you see the shift from system operators in moving towards open and modular systems? How does it affect researchers? And how does the 50 Hertz approach look compared to the past?
Thanks, Charlie. Well, we are the oldest technological university in the English-speaking world. Apparently, we're 200 years old. So in the US, that's a lot. Let me first thank you for giving me this opportunity to participate in the research challenge. How do I see this move? I see it with a lot of excitement. It's a necessary and potentially unique opportunity that we have to change how systems have been developed over so many years. And with that comes a lot of opportunity to rethink how we carry out processes. An example was the dynamic security assessment. So how do we rethink how we build those processes? So I see it with a lot of excitement. I don't work in a utility. I work with a lot of them over the years, and I also see it as a challenge because it's going to require changing our heads. And that operating system is the most difficult to modify. Now, with regards to the research challenge, it's a unique opportunity really to work on real-world problems. What was exciting about this research challenge to me was that the question, at least the ones that I know a little bit about, were posed from the bottom up, from the end users and involving the end users. So I am meeting regularly with the people of this project and EnergyNet and with 50 Hertz, and they're providing weekly feedback on what their exact needs are and the evolution of how the project is going. And this is a very rewarding experience because they're so involved because eventually they have to use the product, which normally in academia, we write papers that nobody reads. So it's quite exciting. And finally, the last piece was, I forgot the last piece.
Just about 50 Hertz approach to things compared to the way you've done it previously.
Right. So, I mean, I have been very gladly surprised with the efficiency of the process of running a project. The application stage was super efficient. We submitted our slides, and we had 2 interviews. In my past life in Europe, I was doing FP7 projects, this amount of paper. So, together with the approach of building these bottom-up questions and making the administrative process efficient, this is really a fast development cycle. And it reflects a lot of what the spirit of MCCS is, right? That we introduce a modular system where you can innovate quicker and use, agile, apparently, and these kind of approaches. So it's very exciting, right? It's also very challenging at the same time because, in academia, we use metrics that are meaningless, like, how many papers you get published and cited, whereas I would like to have a metric of how many people actually use my product. But that will require us as researchers trying to figure out what is it that we value in the long term. I'm kind of hitting that point in the life that I don't see writing papers that nobody reads a motivation. I would like to leave something in my life behind me that I can look with some sort of respect. So.
A great perspective on a new way of doing business.
Thank you.
Thanks. Thank you, Charlie.
Thank you.
I will read your papers, Luigi. But I hope we also have a product by the end of next year that we can have in the system operation part. We come now, so we had the why on NSOA level. No single provider can do everything. We had a bit of the what from researchers, from the industry, from TSOs and DSO. They're all going in the same direction. How do we cooperate? Let's speak a bit about open source, and let me invite Energinet on stage, Thomas. And this was a very interesting experience for me last year. Energinet developed a load frequency controller. So they have something similar than MCCS, but it's not a T-bone, it's a Lego. So we said, okay, you developed it, you went live with it with Marian Picasso, we want to have it, you want to give it to us? Easy. It was not so easy. We spoke to some legal persons, and we had many constructive discussions over a year. So apparently, if someone wants to give you something and you want to take it, it's not that easy. And there were some late-night emails between our COO, Dirk Biermann, and the CIO of Energinet. But we believe open source may be a way to solve this. But I would like to ask you, Thomas, what happened? Why was it so difficult to cooperate, and how can we move forward? What is the view from Energinet?
Yeah, hey everybody. So, yeah, my name is Thomas. I'm the head of architecture in Energinet. I've actually only been in Energinet for a little over a year, and this industry is actually new for me. So bear with me, guys. But still, there's a lot of recognition in this topic that I take with me from the other places I've been before. Thank you for the question there. So in Energinet, we have been working towards embracing open source software for several years, actually. We see it as a way to, being a small country, being a small company, as a way to accelerate innovation, to strengthen cooperation and collaboration, and then create more robust software. And as you mentioned, in collaboration with 50 Hertz, we have worked specifically on trying to sort of move further on that open source agenda with the LFC program there, or the LFC platform. And as you said, we ran into some problems, not with the technical side of the thing itself. That actually worked fine, but the thing about us being a state-owned company in Denmark, we actually had issues about just sharing the software with you guys. That had to do with state supporting specific companies and so on. So in the end, we had to figure out a way that we could collaborate around this without breaking the laws, and open source was the way forward there. It took a little while, actually, because we had as many people in Energinet as I suspect that you guys have in your companies that see open source as a problem more than a solution, actually. So what are the security concerns with open source and other stuff? But luckily, I can say that just recently we had open source as a concept or as a viable way forward approved in our strategic portfolio board in Energinet. So now it is sort of the way to go for us, and we don't have that part as a hindrance anymore by moving forward. And so my hope, or not only my hope, I think I speak for all of us in Energinet, is that we can move on from a more structured development in this open source era, instead of just the ad hoc way that we have moved forward until now. We can maybe establish a common governance, common licensing models that will make it easier for us to share and reuse our software. And actually, maybe we can even create a culture where open source is not just a technical possibility, but really a strategic necessity. So yeah, it's not just a way to develop software, or it's a way to think about collaboration, innovation, and system operations. And it's really a mindset that we need to carry on going forward here. And just, you know, to closing off here, I think what you've shown today, all of us, all of you during the day, really, I think personally, it's the first time I've seen MCCS, and it really lays the foundation for something great moving forward. Yeah.
Thank you. Just to add one thing before I go to Lucien. So our digital committee also approved that we go open source with one of our modules after this rather interesting and traumatic experience with the legal people. We went to all of our departments, to the security department, to the regulation department, to the strategy department, and Christian Merz, one of our colleagues who's here, he did a great job. He interviewed all of them, and they basically gave the feedback, you can go open source, even though you are a critical infrastructure and system operator. If you follow a few guidelines, that's fine. But Lucien, you work for the French system operator RTE, 70 million French people, you are critical infrastructure, and you are the most advanced in open source. You actually put your source code up open source, and you didn't have any problems in terms of security. You did manage to convince your regulator, and you see it more affordable. Can you share a bit with us, how did you do it? How did the French do it? Just to finalize on this, the topology optimizer is developed open source. We will now do a cooperation. We developed something together with Tenet. We will put it open source, and you will reuse it. But please tell us a bit about the open source experience from the French side.
Exactly. So, good afternoon. It's a pleasure for me to be here today to this amazing event initiative. I'm Lucien Balea. I'm Deputy Head of R&D at RT and also leading the open source strategy. Very briefly, our open source strategy started in 2018, and the motivation was the conviction that the traditional way of acquiring our software, meaning either buying it off the shelf or developing internally our own solution, would not scale. It would not fit our future needs, especially in terms of pace of innovation with constrained resources. So I like your word, Thomas, strategic necessities. That was the starting point. And then we had the intuition that the open source model collaboration that was massively adopted by many other industries, telecommunication, automotive, could be a solution for our problem. So we started the collaboration with the NIX Foundation that eventually led to LF Energy. And from the start, a cornerstone consideration was to achieve a trustable open source collaboration model. And trust has two facets here. So there is a governance aspect and a technical aspect. From a governance aspect, the point is how to propose a governance model that can be trusted by all parties, that if a third party invests in a project with us, that their interest can be preserved in the long run, irrespective of what RT will decide tomorrow. It also has an efficiency aspect. So how can we have a trusted governance framework that can be implemented very fast to create new projects? And one challenge in that perspective was to learn and to acknowledge that sharing IP through an open source license that can be for free does not destroy value. And in fact, it can even generate more value than keeping it proprietary. And then from a technical perspective, of course, we are talking about software that is used for critical applications at the TSO. So how can we make sure that this collaboration will deliver state-of-the-art software in terms of quality, in terms of maintainability, evolutivity, cybersecurity? And this consideration motivated the partnership with the Linux Foundation. And actually, the solution was very simple. Just copy-paste the proven model, the proven framework, the proven practices that work for other industries, especially the telecommunication operators, for instance. So where are we today? We have, under LF Energy, two flagship projects. One is called Possible. It's about power system analysis and simulation. The other one is called CPAS. It's about creating a platform that can host and run substation automation and protection applications in the form of software instead of buying devices. And LF Energy helps this project to apply the best practices, especially in terms of cybersecurity, among others. We got in-depth security audits, and what I can say is that today, internally, these two projects are really considered as highly successful, even compared to internal standards. So we are learning from open source collaboration, and these lessons learned help also our internal projects to get better practices from the cybersecurity perspective. Then, in terms of efficiency, what can I say? These projects today benefit from leverage from third-party contributions. So in the possible ecosystem, we have increased adoption from the TSOs community. We have software service companies like Artelis that are contributing to them. If I'm talking about the CPaaS project, so CPaaS, it started in 2019 with 30 words on one slide. It's in production with partial functionalities at Artelis since 2023, and currently there are 2 demonstrator projects running to qualify it for protections for really critical functions. One is by RT in collaboration with Schneider Electric and ABB, the other one run by National Grid in UK in collaboration with GE. And we have also other companies like Savoir-Faire Linux contributing and investing into this project. So this is the kind of achievement that we would have never achieved with a proprietary model, and that open source allowed. And this is a clear illustration that sharing IP can create more value than keeping it proprietary. I will stop.
Thank you. Thank you very much. Hitchell. Okay, thank you very much, everybody. And now I have the pleasure to introduce our CEO, Stefan Kapferer, on stage to give some words about what he thought about today and how we move forward.
Yeah, it's my pleasure and my privilege to sum up this 2025 MCCS Checkpoint event. And like it mentioned by Dirk at the beginning of this conference, the good news of the closing remarks for this year event is these are not the final opportunities to discuss and share views and expertise. With the Global System Operations Summit, which will be happening for the first time this year in Berlin in the next 2 days, I think, Mirko. It's a great opportunity to go ahead and to discuss what we have heard about today. I was asked to say a few words about the need for international cooperation. But having listened to all the colleagues from Europe, from Singapore, from the US, and from the non-independent state of Thuringia at the moment, non-independent, I think it's obvious. We have the same challenges ahead of us, and we have the same limitations, and this kind of international cooperation is key. And especially in a period where we all have noticed that geopolitical tensions are becoming more severe and more risky for all of us, I'm really proud to hear from so many of our colleagues that international cooperation is welcomed, and we are working together to solve the challenges ahead of us for the system operation and the energy system of the future. I was also asked to underline the need for innovation. But I can imagine if you haven't listened to everything we have heard before the coffee break, we all have noticed that innovation is on the way. There are big steps forward in the MCCS project, and it's urgently needed. Because having in mind the energy trilemma of sustainability, of system stability and affordability, a few things are obvious to me. And one colleague was not at stage, a colleague from Chile. I met him in the coffee break, and I was totally impressed that a colleague from Chile is present in Neuenhagen to look at this event. And then we shared our views on the energy systems in Chile and in Germany. And it was really interesting because he said to me, yeah, our share of renewables in Chile is 77%. And last year in the 50 Hertz control area, it was 73%. Yeah, I haven't been to Chile till now, but I think the wind generation is a little bit more stable as it is in Germany. Maybe it's the same with solar. But nevertheless, the target, having an energy system in the future which is based mainly on renewables and which is nevertheless a stable system, is the same target. And this aspect of having the same challenges ahead of us and at the same time the same willingness to create a climate neutral electricity system, it's a great movement of all TSOs, DSOs, academia, and of course also regulators and companies in the future. Talking about system stability and affordability, and we all know in all our countries, affordability of the electricity supply of the energy system is back on the agenda, and it's a priority back on the agenda. It's relevant for me to say that innovation is also key not only to manage the challenges of system stability in the future, innovation is also key to make it affordable. It sounds a little bit crazy maybe, because we all have learned it's a lot of investment needed to make innovation happen. But in the complex electricity system of the future, without digitization and without innovation, it will no longer be an affordable system. And that's the reason why I'm really happy and grateful that though many of you shared your views and gave the clear commitment that cooperation and open source logic is maybe something we can share for the future of our system operation. So I hope you enjoyed this event today here in Neuenhagen. And I'm sure you will enjoy also the Global System Operations Summit tomorrow and Friday in Berlin. Enjoy your visit, enjoy your trip, and please keep alive this fire of international cooperation to manage our system safely and affordable also in the future. Thanks a lot.
Dear guests, and with this outline of Stefan, and thanks a lot, Stefan, this means a lot for us joining the Checkpoint event today. We are coming to the closure of the Checkpoint event. And before we are finalize, there is one point which is quite important. I mean, you have seen so many different aspects around MCCS and the cooperations. And for me, to be honest, this was a really special moment because I had the honorful position of saying hello and now saying goodbye. And I need a big applause for the whole team because a lot of people, by the speakers, by the developers, and a lot of people in the background have made possible that we have this Checkpoint event and having the organization of the Global System Operations Summit. For all of them, please, a big applause. And with that, for the video stream, but also for here in the Transformator Hall, this is the closure of our Checkpoint event. I hope you had inspiring presentations. You had thoughtful and interesting discussions during the networking sessions. And hopefully we see us again to the next checkpoints. And the dates for that, definitely we will announce quite early. With that, thank you very much, and see us to the next checkpoint.